So question, we're given the polar coordinates and we want to find rectangular coordinates. But notice how the R is again our magnitude, or again our radius, if you will. And the power of 3 is our angle, but notice how the angle is in radians. Now remember, pi radians is the same thing as 180 degrees. So if we want to, we can substitute the pi in, 180 degrees in for pi. So 180 divided by 3 would tell us how many degrees that is. So if I clear this off and type in 180 divided by 3, you get then 60 degrees. So basically, if I'm constructing the angle in polar coordinates, the radius is 3. So 1, 2, 3, and then we go out 60 degrees. So each one of these is 15 degrees. So 15, 30, 45, 60. So we would be out to that spot there, I believe. 1, 2, 3, 4, and that's 1, 2, 3. So our vector, it looks like if I got myself focused here, that would be our vector. So it has a radius of 3 and an arc of 60 degrees, or pi over 3 radians. So a radius of 3, or again magnitude, a length, if you will, pi over 3 radians. So what I want to do is convert this over to rectangular coordinates. So remember, by definition, I can find the x-coordinate by going r times the cosine of theta, and I can find the y-coordinate by going r times the sine of theta. So if I use the formula, again, since I'm in degree mode, I'm just going to use the 60 degrees. So I can go 3 times the cosine of 60 degrees, and that gives me the x-coordinate of 1.5. Let's see how it says round here. So rounded, then there's 10th on this one. And then 3 sine of 60 degrees would give me then, so 2.6 if I round to the 10th place. Now, if you're going to use pi over 3, you do have to go to the mode and change yourself back to radian mode. If you do that, if you come in here and do then 3 cosine of pi over 3, so pi is above the up arrow, so second up arrow, pi divided by 3. That should be, the calculus should now understand that's in pi over 3 radians. So it does give me the 1.5. And if I do 3 sine of pi over 3, it should know that's in radians and give me then the same answer, the 2.6. So you can leave it in radians as long as you change the mode. Now, the same way for using the calculator. Right now, notice that I'm in the radian mode. So if I go to the second angle, if I want to change rectangular or polar to rectangular, so polar, this will find the x-coordinate. So I can put the 3 in, comma, and I can put the power of 3 in because I'm in the radian mode. And it should give me the 1.5. I can go to second angle number 8, and that will find the y-coordinate. So number 8, and type in the length, the magnitude, and then the angle, the direction, and that should give me my y-coordinate. Oops, didn't quite get that in there right. That looks correct. So I get that 2.6. So if I go over to my rectangular coordinate system, here's my x-coordinate, x direction, here's my y direction. So if I go, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So if I go 1.5, so 1.5 is about here. 2.6, 2.6 is going to be about in this area. So if I come across here, that'd be my location. So if I draw my vector in, it should look similar to what we have over here. So, but now I've got an x coordinate and a y coordinate. So 1.5, 2.6. So notice how again, it still gives me the length of the vector and its direction by using rectangular coordinates. This does give me the length of the vector and it gives me the direction using the length of the vector and rotating it 60 degrees.